As you've heard, we clearly need bio-based alternatives now. And to enable this, we need cost-effective cellulosic sugars, which will clearly drive and enable the renewables fuel and renewable chemicals industry. I'm proud to tell you that today Renmatix has been focused on just that challenge for the last 3 years. And we're here and we have a solution. We think we have a solution which is going to enable that growth in the renewables business and renewable fuels. We can deliver cost-effective cellulosic sugars from non-food biomass grown here in the U.S., in states like Pennsylvania and other states around this country. As much as John is sourcing his sugars from Brazil, I hope someday he's sourcing his sugars from Renmatix locally here. We're going to work hard to make that happen. Similar with DuPont and Vic's organization. And so we've come up with a technology. It's called supercritical hydrolysis, where you heard a couple of the panelists talk about essentially we use water to disassemble non-food biomass into their attractive component sugars. And we isolate those sugars at economics which enable the renewable fuels and renewable chemicals industry. And we have a proprietary process called the Plantrose process. And I want to take you inside Renmatix for a moment, watch our video, and be just as amazed as I've been and enamored with where we're taking this company and the beauty of this technology. So come on inside and watch the video.
Anytime you talk about cellulose, you need to understand the role of sugar.
Well, sugar is the fundamental building block of a lot of the bioindustrial space. Or anytime you talk about cellulose, and paper is made out of cellulose, that's a polymer of sugar. The sugar is all tied together chemically, but it's a long chain of sugar. And so when we talk about doing hydrolysis on cellulose, what we're talking about is cutting that long chain up into smaller and smaller chains, ultimately getting down to that single link, and that's the sugar unit.
So what Renmatix has done with the Plantrose process is to create a new pathway from almost any biomass, including waste biomass or specifically say woody biomass that you could use to make paper, same kind of sources. And that's a real breakthrough because it allows us to build a fuels and chemicals industry on a broadly available, inexpensive source of biomass yielding incredibly inexpensive sugars to build a new renewable fuels and chemicals industry.
Well, I think we really take advantage of Mother Nature. In Mother Nature, there's a number of sugars combined. We just need to figure out how to break them apart. And we break them apart using just water at elevated pressures and temperatures in a very fast way.
The Plantrose process primarily relies on water and heat to do its work. Supercritical water allows us to use just water to dissolve the biomass.
Supercritical is a term that refers to the fourth state of matter. Most people know solids, liquids, and gases as the normal phases of matter. In a supercritical state, water becomes something like a liquid and something like a gas.
Well, the amazing thing about the Renmatix Plantrose process is that all you need to do is, at a very fundamental level, take the biomass, you put it in a slurry, you put it into a fluid, and you raise the pressure and the temperature of the fluid in a very controlled way to a very precise point for a precise amount of time, and then magic happens, and you get the constituents out. And the pieces that fall out are not something indigestible like a wood chip, but the pieces that fall out, that's what you started with. The pieces that fall out are sugars, which are very valuable.
As you heat up water, you eventually reach the point where it starts to boil. And there's pressure that's associated with the vapor that's coming off. You can actually cap that pressure and force that vapor stream back into liquid just by keeping pressure on the water. And if you squeeze it harder, you can condense it back. And you can go back and forth like that as you increase in temperature up to a point, the point that they call the supercritical point. At that point, you can no longer compress the water back into a liquid phase. You now have what's something like a liquid, something like a gas. There's lots of interesting things that happen once you go supercritical.
When you raise the temperature and pressure further to supercritical conditions so that the water starts to behave like both a liquid and a gas at the same time, cellulose actually becomes soluble in a simple substance such as water. If you take a wood chip and drop it in a glass of water, it will sit there. But if you take that water to supercritical conditions, something dramatically different, something magical, and something incredibly simple happens. The cellulose essentially falls apart.
Well, I think supercritical fluids used in this way intuitively sound expensive, but with a combination of a good fundamental technology like supercritical fluids and a good engineering design, you find the proper ways to harness excess energy back in the process such to make it a cost-effective solution.
We have a process down here in Kennesaw, Georgia, where we have scaled our reaction. We know the components of it, and we can take that to a commercial scale. We're going to have very cost-effective economics, better than corn in the U.S. and competitive with Brazilian cane in our first facility. So we're really excited about our economic part of our story and how that's going to enable the industry.
And we are operating a process out here that operates at a 3-ton per day level. That's a significant scale up. I think it's larger than most players in the space. And it allows us to really demonstrate our ability to make the sugars using the Plantrose process and distribute them to customers and let them test it out on their own process. So far, we've had very good feedback. We've had a lot of interest in the fact that we are capable of making large amounts of sugars today.
We've assembled a team of chemists and chemical engineers who've done this, similar processes for big companies such as Dow, Union Carbide, Roman Haas, and what have you. We're bringing that expertise as we scale what is already a proven reaction pathway. And our intention is to design our first manufacturing facility where we would make roughly 100,000 tons of dry sugar on an annual basis. As we make more and more sugars from our process, we'll become smarter. We'll probably hire smarter engineers in the future too. Both those things will help us take the costs further down over time.
Well, sugar is the fundamental building block of a lot of the bioindustrial space. Sugars can be used to make a wide variety of things, from fuels to chemical intermediates to polymers and to other higher value products. Most of these people are looking to try to replace existing products that were generated originally from an oil-based feedstock.
Renmatix, like many of the ventures which we call Grand Challenge Ventures, the Grand Challenge Venture is one where you imagine something you'd really love to be able to do that would make a huge difference in the world, and you try to imagine a technology that would do that. So Renmatix started with this idea that by taking biomass to this high pressure and temperature that you could cause it to disassemble into sugar. And that's something that's worth building a company around, a really big idea. And that's what Renmatix has, is a really big idea.
The thing I like about Renmatix is the disruptive approach, the unique approach being taken to develop cheap sugars. My view is that Renmatix is on a different cost curve, a different substitution curve than others trying to develop cheap sugars, that so we can become more dependent upon a biofuels or a biomass economy for developing sugars and ultimately fuels and chemicals.
Personally, it is about jobs. I mean, obviously a new industry, and we have the opportunity to help employ people in rural parts of the country, and we're pretty proud of that and excited about it. It's also economically attractive for us to do so because our starting point, our biomass, is often located in those parts of the country. So there's a significant amount of economic activity will be generated just in terms of procuring, delivering, and using that biomass locally.
We figure if we can make a good sugar from a good source at the right price, that we've done our job, and all of the very interesting technologies that have been evolving over the last 20 years can really be put into the marketplace as well.
What I'm especially interested in is seeing an industrial state like Pennsylvania that has a wonderful history of developing on some of the petroleum-based and coal-based sources for their economic success, to actually now transition to clean tech and transition to substitutes like investing in Renmatix to develop cheap cellulosic sugars.
Well, for me personally, relationships matter. So we're looking to work with companies that really want to bring this technology to the market. And so there's a lot of opportunity for us to collaborate with partners to truly bring this to market. We can't do it on our own, but we're an enabling part of the chain, from biomass to sugar.
Renmatix, like many such ventures, started with just a couple people and an idea. Then we brought in Mike Hamilton, the CEO, and brought a team of really experienced people from the industry. And we're so excited that we've put together this great team to bring this important technology to the market at scale.
We're changing, pretty big markets. The energy and particularly the fuels and chemicals markets are very big markets. And they both know they need to move towards a renewable alternative. And we're an enabling technology from a material perspective to help that happen. Well, I often tell my daughter we're inventing something new, brand new, which is really going to help their generation and future generations to really become less reliant on fossil fuels. As I've said to my daughter numerous times, it's all about becoming less reliant on imported oil. And I think, as Paul indicated, we can't afford to continue to import $1 billion a day, whereas we could generate those local investments and local jobs by the Renmatix process and working with other renewable players. One of the things I just want to demonstrate is that we're doing this. This is real. I mean, we take those wood chips, which you see overpiled on the left-hand side, we put them through the process we've described, using none other than water at supercritical conditions, and we then make cellulosic sugars, which we sell to our partners. This is happening, and so this is not a dream now. This is a reality, and we're, with the help of the state of Pennsylvania and our other partners, we're going to continue to push forward to ensure that continues to happen. And as we've planned for our growth as a company, we thought long and hard about where do we need to be to really have the best chance of success. And we came to two main conclusions. One is we needed material science talent to help us, because we still need help as part of our progress on multiple sources of different types of biomass beyond wood. So we need great scientists, great physicists, great biologists, ideally not in the ocean and hopefully not crystallized, to be ready to work for us right here in Pennsylvania. At the same time, we wanted to work with a state which was blessed with an abundance of biomass that saw a similar vision and a similar interest to what we were trying to achieve. And we found that. We found that right here in Pennsylvania, in Greater Philadelphia, in the King of Prussia.